We are Team Anveshak, a group of 20 plus passionate students from IIT Madras, whose vision is to create a state of the art Mars rover. After a strong performance with Caesar in URC 2019, we present this year's contender, Dark Knight. Inspired by Caesar, the core subsystems have been retained with a healthy dose of optimization and improvements.
The mechanical module set out with the main goal of optimizing to attain a higher degree of precision. To achieve this, each mechanism was extensively analyzed and its performance judged. For traversing rugged terrain, the rocker bogie system was redesigned from the ground up. We modeled the system in MATLAB and designed it to perform well in bumpy terrain. The rocker and bogie links are made of custom fabricated carbon fiber for its strength to weight advantages. The entire motor was shifted within the wheels for increased safety. To reduce the weight and maximum load, the bar differential was redesigned to couple with the rocker bogie at an angle. In order to enhance modularity, the chassis framework has been implemented to switch from science to manipulator mode and back.
Our 5 degree of freedom articulated manipulator is robust and capable of performing a variety of tasks. We have re-engineered several of the couplings to reduce undesirable vibrations that make control difficult. To further improve its capability, we performed workspace calculations and increased the link lengths. The end effector now reaches 38 cm below and up to 1.1 meter above the mount point of the arm. We have experimented with an adjustable worm gearbox to improve meshing of the gears. We have implemented an end effector with both encompassing and pinching grips to grasp a large variety of objects with ease. It is an underactuated 5-bar mechanism with mechanical constraints to activate pinching grip when a tip to object criteria is met.
The entire circuitry, powered by two 24-volt LiPo batteries, is housed in a modular electronics box. The Jetson Nano forms the core of all the computations on the rover. It interfaces with two networks of STMs that communicate over an I2C and a canvas. The shift to canvas for the manipulator reduced noise in the communication. The PCBs were custom designed to enable modularity in operations for easy assembly and debugging. 4 cameras are placed at optimum positions for different operations like picking up, servicing and traversal. Feed from any two selected cameras provide real-time view of the surroundings of the rover. In addition, a ROS-based GUI allows us to easily set up, monitor and debug the rover's operation.
Our communication setup consists of a directional antenna at the base station and an omnidirectional antenna mounted on the rover operating at 2.4 GHz. The setup is capable of communicating over a distance of 1 km, even in the absence of line of sight. For the autonomous task, a control algorithm is implemented to continuously align the rover towards a destination direction based on data from an IMU sensor and a GPS module. The ROS wrapper of Alver is used for the air tag detection, and a search algorithm based on spiral navigation is in its testing phase. A stereo camera, which gives a 3D map of the surrounding, is used for obstacle avoidance.
The science setup consists of two parts: the onboard laboratory and the soil collection mechanism. The soil collection module is a 2 degree of freedom open chain system which digs into the soil using a scooper and deposits it to the lab via combined motion of the scooper and a linear actuator. To support our initial tests for proteins and lipids, tests for carbonates and ammonia were added to differentiate between the soil samples accurately. Data from the temperature, pressure, humidity and luminosity sensors help us determine if physical conditions are conducive for the existence of life. The microscope on board with adjustable focus is used to determine the physical attributes such as color and texture of the soil and rocks. Cameras placed at different positions of the laboratory provide a live feed of all the operations taking place.